Hey everyone, so in this video we're going to be learning about something called Lewis dot diagrams, and we're going to use them to make visual models of ionic and covalent compounds. So really quickly, it's been a while since we talked about this stuff, so let's review. Ionic compounds, you can go ahead and copy this down on page 51 with me. In ionic compounds, we have a metal combined with a nonmetal. And hopefully you remember where the metals and nonmetals are on the periodic table. If you don't, remember the metals are everything on the left of this jagged staircase line, except for hydrogen, which is a nonmetal. The nonmetals are everything on the right. Yeah, there are a couple of elements called metalloids in here, but for the most part, you just need to know metals, nonmetals. So on an ionic compound, we have a metal and a nonmetal, and usually the metal gives an electron. So an electron is transferred, or it moves, from the metal to the nonmetal. And that makes the metal positive and the nonmetal negative, and then they're attracted to each other, and that's why they're a compound, because they're attracted to each other. Now, covalent compounds are different. A covalent compound is made up of just nonmetals. So you can have 2 nonmetals or 3 or a lot more. So nonmetal plus nonmetal. And in covalent compounds, the electrons are not transferred. So the electrons are shared between the atoms in bonds. Okay, so it's really important that you know those differences between ionic and covalent compounds. Remember, covalent compounds involve sharing electrons in bonds. In ionic compounds, the electron moves, and then the ions that are formed are attracted to each other, but they're not sharing electrons. Okay, just a couple other things you need to be aware of. You need to remember how to find the number of valence electrons. So remember that just is by the column the element is in. So this column has 1, these ones have 2. We skip over the transition metals, and we've got 3, 4, 5, 6, 7, 8. All right. The other thing you want to remember is that all of the elements want to have 8 valence electrons. That's oversimplifying a little bit. Some of them would rather have a different number, but for the most part, they want to have 8 valence electrons. So, for example, oxygen only has 6 valence electrons. It's going to want to gain 2 more valence electrons to have 8. So that's going to be very important in this process. Okay, so we're going to do some Lewis diagrams for ionic compounds first. Okay, so we're going to do a diagram for NaCl. So what we're going to do is we'll write the formula, it's NaCl, and then we're going to write the symbol for each of the elements. So I'm going to write Na, and then I'm going to get a different color for Cl. And then I'm going to draw dots for the number of valence electrons for each element. So sodium has 1 valence electron since it's in that first column. So I'm going to draw a dot. I can draw anywhere around the sodium. I'm going to draw it up here. Now, chlorine has 7 valence electrons because it's in the 1, 2, 3, 4, 5, 6, 7th column. So I'm going to draw 7 dots. And the way that you usually do this is you draw 2 dots on each side of the atom. So 1, 2, 3, 4, 5, 6, 7. All right. Now we have to figure out what's going to happen when these elements transfer electrons. So as you can probably see, sodium is going to give its electron to chlorine. So we're going to draw an arrow going from sodium to chlorine. And then I'm going to redraw the elements now that the electrons have been transferred. So sodium now has no electrons. I say it has no valence electrons. It actually has an energy level below the one we were showing that has 8 valence electrons. So it actually has an octet. And then chlorine has 1, 2, 3, 4, 5, 6, 7. And then we're going to put its 8th electron in black because it came from sodium. Now this changes the charges of these elements. Since sodium lost an electron, it's going to be positive. And since chlorine gained an electron, it's going to be negative. Okay, let's do another ionic compound. We're going to do MgCl2. So this time, I'm going to have a magnesium, and then I'm going to have 2 chlorines. I'm going to draw them on either side of the magnesium. So if we look at magnesium, it's in this second column, so it's going to have 2 valence electrons. So we'll draw 2 dots. And then we already looked at chlorine. It has 7 valence electrons. So we'll draw 7 for that chlorine and 7 for this chlorine. Now both of these chlorines want to have 8 valence electrons. Magnesium wants to get rid of these 2, so it's going to lose this electron to this chlorine and this electron to this chlorine. So when we redraw it, magnesium has lost 2 electrons, so now it's a positive 2, and both of the chlorines have gained 1 electron, so they are both negative 1. Okay, and this matches what we know about the charges. You guys remember how to find the charges of the elements? It goes +1, +2. So we know magnesium would be a +2. +3, skip, -3, -2, -1, skip. All right, so that's Lewis diagrams for ionic compounds. Now, Lewis structures, or well, we can just call them Lewis diagrams for covalent compounds, are a little bit different. Okay, I'm going to show you how this works. So we're going to start with F2. So this is just 2 fluorines, and they are both nonmetals because they're both fluorine. So they are going to share electrons rather than transfer. So let's look at fluorine. Let's look at how many valence electrons it has. And it's got 1, 2, 3, 4, 5, 6, 7. So we're going to draw 2 fluorines, each with 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, so what happens when we have covalent compounds is that neither of these atoms wants to give up their electrons. Instead, they decide that they're going to share in order to get an octet. So if they share, we're going to actually connect these 2 electrons with a line because they're going to share those electrons. So now both of the fluorines get to count both of these electrons as their own. So if we look at this fluorine, it's got 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, so it has an octet. And this fluorine also has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, so it has an octet. And these are being shared in a bond. So this line is showing that we're sharing these electrons in a bond. Now sometimes in these structures, they'll leave off all of the dots that are not connected, and they'll just draw it like this. And so you'll sometimes see structures just with a line. In fact, that's often how they'll draw them. Okay, one more covalent. We're going to do PCl3. Okay, so again, we know this is covalent because we've got two nonmetals. I'm going to draw the P in a different color from the Cl's. Okay, we already know chlorine has 7 valence electrons. So I'm drawing 7 valence electrons for each of those chlorines. And then we're going to draw 1. Okay, so we've got 5 valence electrons for phosphorus because it is in the 1, 2, 3, 4, 5th column. So phosphorus wants to have 8, chlorine wants to have 8. And so what's going to happen is this chlorine is going to share this electron with phosphorus, and this chlorine is going to share this electron, and this chlorine is going to share this electron. So we can draw these a little bit closer together over here. So got our chlorine, and our other chlorine, and our third chlorine, and they're all sharing electrons with the phosphorus. So if you count all of phosphorus's dots that it gets to count 1, 2, both the ones that are connected. So 1, 2, 3, 4, 5, 6, 7, 8. So phosphorus has 8 electrons, and chlorine also gets to count both of these electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what you need to remember with covalent bonding is that dots or electrons connected by a line are shared. So they count for both atoms. Okay, so that's how you do Lewis diagrams for ionic and covalent compounds. Let me know if you have any questions.